Hey Science 8s, it's Manchak here. Just doing a quick video for you to introduce Unit D and to run you through the next concept, which is Concept D1. So hey, congratulations, you made it through Unit C. And now we're moving on to something new, and I have to say I am kind of excited about this unit because we are going to be talking about a whole bunch of stuff related to physics, which I think scares some people, but it shouldn't. It's what we're going to talk about this unit is something relatively simple that you guys can manage with very few problems, I'm sure. So I think without further ado, I'm going to introduce the unit to you, and then we are going to jump into Concept D1 and play around with that. So hopefully this works well for you. All right, and here is our concept checklist, and I'm just going to bring you back to this to sort of to remind you that this is on the Google Classroom, right up at the top of the classroom, where you guys can track down information about what's going on in the class and give you an idea of exactly what's going to be covered in each concept. So this is our breakdown for Unit D. There's 5 concepts in the unit, and we're going to go through everything from simple machines to complex machines to mechanical advantage and speed ratio. We'll talk about work, energy, and hydraulics, and then we'll get into evaluating and changing mechanical devices as we go through and talk about, how to make things better, basically. So we're going to start out today with, and I should talk about the general outcomes from the unit. So our goals for this unit to get done are to illustrate the development of science and technology by describing, comparing, and interpreting mechanical devices that have improved over time. So we're going to look at machine stuff, and we're going to look at it with hopefully a new set of eyes and try to get a sense to what's good about them and what's bad about them and what we can improve upon, how things have gotten better as time has gone by. So we're going to analyze those machines. We'll describe the structures and functions of the overall system and subsystems, as well as the parts that make them up. Then we're going to investigate and describe the transmission of force and energy between parts of a mechanical system. And then lastly, we're going to analyze the social, environmental, and context of science and technology as they apply to developing mechanical devices. So we're going to do lots of stuff. That's a lot of fancy words. The first thing we're going to get into is talking about simple machines, and I'm going to introduce you to the 6 simple machines in this lesson, and then I'll switch over to my next thing here, and I want to show you guys sort of what our plan is, and I'm kind of excited about something that I want to try with you. And we'll see how it goes, an activity that you'll get to do around the house and work your way through. So just some general notes about the unit. Welcome to Unit D. We're going to do mechanical systems is what it's called. So it's really all about machines and learning about machines. What are they, how they work, and how do they help us, and how do we make them better, what we can do to improve upon them. So if any of you have any designs on becoming an engineer at some point, or working with mechanical systems in any way, like you like tinkering with cars or snowmobiles, you like building stuff, this unit is for you, because you're going to learn about a bunch of different kinds of simple machines and complex machines that work to make our lives easier and better. We are going to go through the simple machines today, and we're going to learn what these simple machines are, and we'll even play around with a few. There's some pages, and I'll put all of this in the Google Classroom again. There's some pages out there in our textbook that you can use to sort of follow along and learn about these simple machines. Then we're going to have some videos that I will post up later on. I'm just in the process of picking a couple more that I think are going to be really good for you guys to have a look at. And then lastly, we'll do some formative work for the unit. So you guys will do some questions out of the textbook if you want to. I have a worksheet and then a practice quiz. And then before you get to doing the summative quiz, I have a fun activity that I'm piecing together right now, where you're going to do a roundup of some simple machines in your house. and those will be sort of your choice what those machines are. And you're going to do something on an app called Flipgrid that's going to allow you to show me some of those simple machines, what they look like, how they work, all that kind of stuff. So I'm kind of excited to show you guys this unit and to start to work our way through it. So I guess without delaying any longer, let's jump into Unit D, and we'll get in here first. Oh, I got to move my camera for a second so I can hit the present button. Oh, then it goes away. Hang on a second. I'm going to move myself down to the bottom right. You guys can watch me there, and we're good to go. All right, so mechanical systems. These systems will get you moving, you know, because I can't do anything without throwing a pun in, right? So, first section is all about talking about machines that help humans do work. Machines are simply tools that help us do work. So if that's the one thing you walk away from this first section, understand that a machine is something that we use to make our lives easier, to do things for us. Now, we have complex machines, like my cell phone here. This is a complex machine. It is really, you know, a tricky machine to work with. But we also have other machines. Like I'm looking around right now, my the area around me. I mean, we've got a microscope up here that is a complex machine, and it's got a wheel and axle on it, and it's got a whole bunch of other things that do work for us. I have a very simple machine right here, a pair of scissors, and this pair of scissors is an example of a wedge. That can actually do cutting of paper, those kinds of things. So we're gonna introduce a bunch of simple machines in this concept. But before we do that, we've run through these already, so I'm going to skip over them. Before we do that, I want to just do a little bit of a history lesson. If you remember, we started off Unit C with a bit of a history lesson, and we talked about the history of light in Unit C and got a good idea of what's going on there. I want to start out with a bit of a history lesson here as well. So remember, you should be following along on your notes at this point. If you haven't got them out, remember they're in the Google Classroom under Unit D, down in the resources where it says notes and worksheets. You'll find a PDF document of the notes there. So hopefully you have them out and you're following along. So here's a little history lesson on machines. Throughout human history, we've tried to make our lives easier. And who wouldn't want to expend less energy to try to accomplish a task? Why work harder than you need to? Right? And so if we can expend less energy to get something done, that's a win all the way through. Machines, even the earliest simple machines, were very simple, and they served a very simple purpose, to help us do work. Okay? Therefore, a machine is any device that helps us to do work. Don't forget, any of these words that are bolded and underlined, those are vocabulary words, and I want you guys to know those and find a way to learn them, cue cards or whatever works best for you. The earliest machines made their users' lives easier, but were usually powered by human or animal power. What we've done now is we've taken devices like our phones and we've made them be powered off of batteries and other things like that. But they still make our lives easier. Instead of hopping into my car, driving all the way to your house, handing you this presentation, right? I can do all of that stuff with my phone. I could just go and send that with my phone, or I can send it with my computer. So it's a machine that's making my life easier. As time has gone by, we've continued to modify these machines to make them more and more complex. What was something as simple as a shovel, we've now turned into a backhoe. And it does much more work for much more or much less energy. We've tried to make things more efficient to get the same amount of work done by expending less energy. Pages 260 and 261 of your textbook are worth a good read right now. So if you wanted to hit pause and read through those really quickly, you can. I'll give you a moment to do that now. All right, so hopefully you've read those pages. If you haven't, make a note to go back to them later on. So what I want to talk to you guys right now about are simple machines, and that's really the theme of D1. Once you understand what a machine is, let's start to understand what simple machines are. A simple machine is a tool or device made up of one basic machine. Okay, and there are 6 simple machines that we're going to be examining in this concept. And I hope, and this is kind of tricky, is I hope that as we work our way through this unit and you've learned about these simple machines, you're going to walk around your house and you're going to go, oh, wonder if this has a simple, yeah, that's an inclined plane. Or, oh, hey, there's a wheel and axle involved on that. I hope that gets inside your head and it messes around a little bit with you and you walk around your house going, I wonder where all these simple machines are. So there's 6 simple machines that we're going to examine in the concept. And each simple machine can be used in a multitude of different ways. And each simple machine has advantages and disadvantages associated with it. Okay? Engineers work with these simple machines and often use them in combination with each other to accomplish a much more complicated machine. So when I showed you the example of scissors, there's actually 2 simple machines involved in a pair of scissors, making this a complex machine. But I'm going to leave you guys to figure that out and what those 2 might be later on. But there are 2 simple machines involved in the working of the scissors. I'll give you a hint. One has to do with where this little screw is and where it articulates on the pair of scissors, and the other has to do with the fact that these are shaped like a wedge on here. Okay? So there's 2 simple machines involved in that more complex machine that is a pair of scissors. So we're going to use the following terms frequently in this section, and if you walk away with from this page understanding what load and input force are. Okay, the load in this reference is a heavy or bulky thing that is being carried or about to be carried by the thing that our machine is doing. Okay, so it is what we're trying to move with the machine. It is the thing that we are doing work on. Okay, so for a pair of scissors, the load is going to be the fact that I'm cutting this post-it note out. Okay, the load is the post-it note. This pair of scissors works great for small things like this, but if I tried to take this machine and use it to cut something much larger, maybe 15 pieces of post-it notes, it would struggle. So my load is much greater than that pair of scissors will be able to handle. What is coupled with load is something called input force. And input force, remember, a force is a push or a pull on an object resulting from the interaction with another object. So the input force when I'm using these scissors is what my hand and fingers are doing. The force that I can put into this pair of scissors to cause the machine to do what it's supposed to do, which is cut the piece of paper up. Okay, so the load is the thing that we're moving or that the machine is operating on, and then the input force is the energy, the force that we're putting into that machine to make the machine do something for us. I hope that makes sense to you. So the next bit then, we're going to start to get into talking about the different kinds of simple machines. And I'm going to highlight 6 of them for you, and each of them we're going to go into a little bit of detail on. So pay attention to the simple machine and then the things that are going on within those machines. So a lever is the first type of simple machine we'll talk about. A lever is a rigid bar or plank, that can rotate around a fixed point called a pivot or a fulcrum. So if we imagine my pen right here, we can create a lever out of it, right? This becomes my fulcrum, and then my pen becomes the lever. And I am applying an input force with my hand, and we can lift a load on the other end. Okay, this is a simple lever. Levers are used to reduce the force needed to carry out a task, and it makes the job easier to do. However, to accomplish this goal, a lever must move a greater distance than the load does. So what ends up happening is when I'm using this lever, the end that I'm applying the force to, the input force, moves much more than the actual object is going to. Okay, that's one of the disadvantages. So what's great about it is we can reduce the force needed to move an object. What a disadvantage is that we have to move the lever itself a greater distance than the object actually ends up moving. There's three kinds of levers that I want you to know. First, second, and third class levers. A first class lever has a fulcrum between the load and the force or the effort. And that's what we've got going on here. Okay, this is a third class lever. The fulcrum is my finger. The load would be here. My input force is on this end. We have a first class lever, pardon me. Second class lever has the load between the fulcrum and the force or the effort. And so if I think the best idea would be to show the diagram because it's hard to illustrate here. A great example of a second class lever is a wheelbarrow. Okay, because what's going on is the fulcrum is down at one end, the load is sitting in the middle, and then your input force is at the opposite end of the fulcrum. So if you can imagine, I'm putting a load on here, here's my fulcrum, I'm lifting it up like that. That's a second class lever. Okay, the third class lever has the force or effort in between the fulcrum and the lever. And so what we're doing here, lifting this weight, is we've got the input force in between the output force and the fulcrum. Okay, so my output force or my load is over here, and then my input force is actually coming, and this is a weird one here. My input force is actually coming from the middle here, but it's being transferred from that muscle up there. So if you imagine this as one plane, my input force is in the middle because there's a ligament attached to that muscle in the bicep here. And then the fulcrum is where our elbow is. And so when we do something like this, right, the input force is actually coming from here because my bicep is attached to my radius and ulna, which are the bones in my arm. And so the load, which is my pen, is actually being, the force is initiating from here, but the force is being transferred to here, and our input force is here. And then my fulcrum is my elbow in this case. So that's a lever and the three classes of levers. I'm sure if you walked around your house, you'd find other examples than the ones that we have here. And hint, that's something that you guys are going to be doing later on this week when you look at these levers. Well, and simple machines. The second kind of simple machine I want to talk to you about excuse me, is the inclined plane. An inclined plane, also known as a ramp, makes it easier to lift heavy objects, again, using a smaller force. However, you have to exert the force over a greater distance compared to just simply lifting the object straight up. So it makes it easier to get the object from here to here, but you have to run it over a longer distance to make that happen. So this is an inclined plane right here on this ramp. And so your input force is the force that we're pushing this load up. However, the output, so we're reducing the amount of input force that we have to put in. We're still moving the load, but what ends up happening is we have to put that input force into a longer distance. So we still get that load up top to wherever we're moving it, but we're putting it in over a longer distance. The input force is over a longer distance. So if we were to just take that object and lift it up, right, all we're doing is moving it this far to get it up from here to here. But we're exerting more input force to do that. However, if we take an inclined plane, we're still getting the object from here to here, but we have to push it up that much further distance to get it up to that spot. But the bonus of using an inclined plane is that it takes less input force to move it up that inclined plane than it did to just lift it up directly. Hope that kind of makes sense. It's generally useful for small inclines, but the steeper the angle of the ramp, the harder it is to control the motion of an object as it moves up or down the ramp. So it becomes a little bit dangerous at that point. So there's our inclined plane. That's number 2. Number 3 is a wedge. A wedge is similar in shape to an inclined plane, but it's used in a different way. Instead of running something over top of the inclined plane like we do with the like we do with the inclined plane, a wedge is where we actually put the force in a different spot. So what we end up doing with a wedge, okay, if this is a wedge shape right here, is we end up applying the force on the top. And then we push, take all of that force, and we transfer it down to a little point right at the very bottom of that wedge. And that little point at the very bottom of the wedge gets a whole bunch of force pushed on it, and we use a wedge then to split an object apart. So what a wedge does is it increases the force you apply to an object, but it moves a greater distance into the object than the split actually causes. Okay, so unlike a ramp, a wedge can be used in only one direction to push objects apart. Okay, so some examples of wedges, very simple, would be an axe. Right, an axe has a wedge shape to it. Our force is put down here, and that force changes the direction. Is changing direction and taking all of that force and focusing it here and on the sides. The same kind of thing with a knife. A knife is basically a wedge as well. And you look at a very sharp knife, you can't even see that edge that you've created on that very sharp knife. Okay, and so that, sorry, I had to pause there to get some water because I kept coughing. So that's the wedge. So that's 3 of our 6 simple machines. The next one is called a screw. And a screw is simply a cylinder, right? You know the shape of a cylinder. And a screw has a groove cut in a spiral on the outside. So we took a cylinder and then we've cut a groove in that, leaving us with that screw kind of shape. And so the best example of a screw is actually a screw. So that simple machine is actually, go look at one of the screws that you might have around the house, and that would be helpful. Using a screw helps us to increase the force you use, or the output force on the object. So it allows us to move a greater load. And so we tend to use screws often to penetrate into materials using a relatively small input force, right? If you without a, if you tried to push a nail in with just your hand versus trying to screw using a screw, you'll have a lot more success using a screw with just your hand than trying to pound a nail in, if the whole purpose is to get something into a piece of wood. A screw is also used to convert rotational motion to linear motion, and a grain auger is a great example of this. And I'll see if I can find a video to post up to you guys to show you what a grain auger looks like. If you don't know, most of you probably do. It's also known as an Archimedes screw. The disadvantage of screws is they often move objects very slowly. There's no speed involved in it. It slows things down quite a bit. So this is a simple screw. And so what you would do is you would put your input force over here. The output force would be basically here. And as you screw that object in, it sort of pulls itself down into the object. This is an Archimedes screw. And so what would end up happening is we actually use this function to have input force actually at the top here, and that's drawing water up in this screw assembly here to bring it up from a lower area to a higher area. Again, it makes it easier for us because we don't have to do much work, much input force to crank that screw to bring the water up compared to actually taking all that water and just lifting it up bucket by bucket at a time. You're going to input more force to just lift it up each time than you would by just cranking. Okay, so there's screw. That's 4 of 6. 5 of 6 is a pulley. A pulley consists of wire, rope, or cable moving on a grooved wheel. I'm sure most of you have seen a pulley before. This is what a pulley is gonna look like, or a pulley system will look like. And a pulley may be made up of one or many wheels and can be fixed in place, or it can be movable. And the more wheels in the pulley or pulley system, the less input is needed to move the load. And so often we use, something called a block and tackle, something like that. If I wanted to get, a piano from the first floor up onto the second floor, the amount of input force I would have to put in and the number of people that I would need to take that piano and lift it up to the second floor, if we could even do it, is ridiculous. However, if we used a block and tackle anchored above, which is basically a whole bunch of pulleys woven together, and that's kind of what you're seeing here. This is a block and tackle, a whole bunch of pulleys woven together, and we just pull on a rope. What's going to end up happening is all of these pulleys on here, all of these pulleys on here end up reducing the amount of input force that we have to put in to lift our load. Okay, so the block in a block and tackle is the anchored part at the top. The tackle is the part that moves at the bottom. But notice that there's 4 pulleys involved in this, and each pulley reduces the amount of input force I have to put in over here to move the load over here. The disadvantage to this is that we have to move a greater distance to apply a greater force, and so we got to pull a lot of rope. It's not going to be 1, 2, 3 pulls and we've moved it up. We're going to be pulling a lot of rope through that block and tackle to get that piano up onto the second floor. But we could use a wheel and axle to increase the speed of this, like we do with the wheels on a bicycle. And we can talk more about. Oops, sorry, I was jumping ahead. That's really weird. I was reading the wrong one. The drawback though is that we have a greater distance to move it, so it lets us lift larger loads, but we have to do a lot of distance covered to move that object up for our pulley. Okay. The last one is a wheel and axle, and a wheel and axle is a combination of 2 wheels of different diameters that turn together. Okay. What happens then is a longer motion on the wheel produces a shorter, more powerful motion on the axle, or vice versa. Okay, so think of the steering wheel and the steering column in a car. They form a wheel and axle, and so your steering wheel, you don't put much effort on that steering wheel to turn the wheel itself. But what that does is it produces a much stronger force on the little axle, the steering column, that goes into the vehicle itself, that causes the wheels to turn. Because you would need a fair amount of force without having a wheel and axle taking. If you tried to turn the wheels with just holding the axle, it would be almost impossible for you to do. So that large wheel that is your steering wheel allows us to move a great distance around. So you move that wheel a lot to turn the tires, but that translates into a lot of force, output force or load force, on that small axle that is the steering column. So the drawback again is you have to turn a greater distance. You turn a larger wheel to apply the greater force. And the wheel and axle can also be used to increase speed, like the wheels on a bicycle. So think of the wheels on a bicycle to opposite to a steering wheel. We move our pedals, which is a little wheel, which is hooked up by a chain to a bigger wheel. So it's still a wheel and axle, but the axle is where your pedals are. The wheel is the actual wheel of your bicycle. And so we apply a lot of force to the pedals to make those wheels spin, that big wheel spin faster, so that we can go faster on our bikes. Okay. So these are some simple examples of wheel and axle that we have in our homes that we might find at some point along the way. Okay, and I'm not going to get into these in detail because when we get into doing your activity later on in this week, I'm going to have you guys going around the house and finding me nice, hopefully unique examples of simple machines that you can find in your home. Okay, so maybe start thinking about that at this point and see if you can come up with them before you get onto that. So what are the effects of simple machines? Simple machines can be used to do the following. They can change the direction of a force. For example, a pulley on a flagpole. We're changing the direction of the force. What we're doing is I'm pulling down on the rope on my flagpole, and what's happening? The flag is going up. A downward force is being transferred into a direction of an upward force. Okay? We can multiply force by taking the screwdriver and just twisting it. It's a simple wheel and axle system, and I'm moving the bigger wheel, and the screw, the point where the screwdriver touches the screw is the axle part. I'm multiplying the force that I'm using at that point. We can increase or decrease speed. For example, scissors allow us to do that. Bicycle wheels will allow us to do that. Or we can transfer force. And we can transfer force, for example, a staple remover, which is some kind of a lever, I'm not going to tell you which kind, that allows us to transfer force from where we're squeezing to where we're actually removing the paper. So that's what simple machines can do. It would be a good idea to make sure you have an idea of at least a couple of the things that simple machines can do for us. Changing direction of force, multiplying force, increasing or decreasing speed, or transferring force. And maybe have an example for each of those, a type of simple machine or machine that allows us to do that. Remember, a simple machine can increase the force that you apply or change the direction of force, but there is a cost. The force you apply has to move further than the load does. So there's always a cost associated with this. Well, I think it's true anywhere. You don't ever get something for free. So we may get to make our task easier, but we may have to move it over a long distance in order to make that happen. Okay, so this I will ignore right now. We're going to just jump right to the end. That is the stuff I need to teach you about for Concept D1. What I'm going to get you guys to do now is, if you need to, go back and have a look at some of the things that we've talked about. I'm going to place a video somewhere or two in the Google Classroom under D1 resources, videos, etc. That'll go through some of this simple machine stuff again with some animation, so you just don't have to watch my hands flinging around as I'm doing things. Have a look at the questions on page 268 if you'd like. There's also a worksheet in the Google Classroom under Unit D, Resources, Notes, and Worksheets, and you can find it in there. And then the key will be under Unit D, Resources, Keys, okay? Or worksheet keys or something like that. And then the other thing that I'm going to post up for you guys shortly, if it's not there already, is an activity for you to do, which is going to have you bopping around the house looking for simple machines, and then recording things on Flipgrid, if we can make that work, and showing me the examples of the simple machines that you found, and explaining to me a little bit about those machines. So I hope that works for you. Don't forget, you'll also have a practice quiz that I'll put up on the Google Classroom. Do all of this other stuff first before you do the practice quiz, then take the practice quiz, then please wait for feedback from me. Don't just jump right into the summative quiz if it's up there already. Wait for some feedback, get some feedback from me, and before you get into doing the rest of it. Okay? And I believe that is all I've got to tell you guys. Thank you for playing along. I have lost my thing, so I'll just cut this out at the end. I hope you guys stay healthy, stay safe out there, and we'll talk again soon.